Good morning, everyone. So we're going to talk a little bit about platform engineering and Lego. Everyone loves Lego. If you don't love Lego, then you should really go and have a good hard look at yourself. And I think today, at first, we came in at last minute, as Ross mentioned. At first, I was a bit worried, not sure how this kind of session would land, but Anthony's session this morning was very good to kind of introduce some of the stuff that we're going to be talking about. So we'll get straight into it because we can both talk a lot and we don't have a lot of time. So my name's Stephen Tulp, so I'm a tech strategist at Insights. I've been there for about 8 years now. I wear many hats, but one of the hats that I'm wearing at the moment is to build our internal platform engineering function and working with the various different teams there across that. And hand over to Trent.
Hi, I'm Trent Steenholdt. I have just recently returned back to Insight about 6 months ago. I'm still in my probation, so let's hope this talk goes well today. I worked with Tulpy about 5 years ago and returned back into the platform engineering team within internally, and we've been working together for the last few months building this out, so very excited to be here today.
So what's this platform engineering thing all about? So you could probably go out there and see different concepts and different views on things. So this is my view. So platform engineering enables self-service and promotes golden paths to encapsulate common patterns and practices, creating these building blocks. So that's where this Lego concept comes from. But the main idea is to reduce the cognitive load on developers in a cloud-native era. So those pieces of highlighted text there kind of really cover what we'll go through today, but it's really about this new methodology that seems like it's something new, but realistically it isn't, and then we'll put that into perspective of how it's really about enabling the developers and reducing their cognitive load so they can go off and develop features and do what developers do rather than trying to solve everything in the day-to-day world.
So in terms of how this looks, platform engineering, you probably have been doing this yourself already. It's a concept that is just kind of alluded to around in terms of like infrastructure as code and DevOps. So if you're having a DevOps culture, you work in an agile mindset, you're pretty much doing a little bit of the fundamentals of platform engineering. So we start with infrastructure development. So infrastructure development is the infrastructure's code component. You probably have engineers in your business, in your organizations that are working with infrastructure as code. There's literally a talk next door talking about Terraform. We're Bicep guys, so that's why we're here. The tooling and automation, we've got things like Azure DevOps, we've got Jenkins, we've got AWS Code Deploy, we've got all those tools that are available to us, and platform engineering is about picking those right tools for the team to use and consume. Cross-functional collaboration, so this ties in with that DevOps pillar. It's all about collaboration, so you'll learn in a few slides about where platform engineering kind of becomes this service provider inside your own business. But it's all about collaboration, providing the wheelhouse, the platform, the concrete slab as you call it, to really build upon that system. Continuous improvement, so again, in that life cycle and innovation and behaviours around that, it's about making sure that we just continuously monitor, test, and I guess that keynote this morning was really great about talking about observability and monitoring across the entire solution. So platform engineering is something that you are probably already doing, but it's something that we're going to kind of dive into today, and around these kind of 5 concepts, you'll understand how it is its own defined role across an organisation.
So how did we get here? So I guess looking at most people in the room, someone like Hamish has been around for a long time. Remember before cloud, there was
saying he's old.
So we talked about, and Anthony did say this earlier as well, right? We're going from this monolithic architecture into microservices and beyond. So infrastructure started as servers, infrastructure, tin, things in the data center, and now we're kind of moving into kind of cloud components. So as a developer, originally started, you're developing code. Then as we go through the different stages, now you're shipping code, now you're running. This is where the whole DevOps kind of mindset came in. So that load and the responsibilities of the developer has kind of expanded. So when you look at all of these new technologies starting from IDE through to Git and all of these other new technologies now, and everyone's favorite square peg round hole Kubernetes capabilities, it's a lot of stuff to take on board. And taking away, I guess, that concept of being able to dev and deliver features and kind of products to the business, because there's just so much things across security, automation, infrastructure, governance. Like, it's very hard to kind of keep across all of that stuff today.
So what does that look like in the real world? So I kind of mentioned it earlier that, yes, we are all in effect platform engineers. You're probably doing this in your role when you're building a product. You start with the infrastructure and you're building the ISE templates, and then once you've just started deploying that, then you're building your MS Build, .NET application, deploying on top of that. But as Tulpy's alluded to, it's all about reducing that cognitive load. So for developers, it's not needing to be responsible for the infrastructure as code. It's a dependent person or dependent team that are responsible for making sure those templates and those orchestration files, if you want to call them, are stock standard for across the organization. So when a developer moving between teams doesn't necessarily have to relearn all the ropes of all how the things are coupled together, and is able to speed their development a lot quicker. Same with DevOps engineers. It's a tying in of making sure that those people can focus on more of the collaboration rather than necessarily making sure that the platform ecosystem is set up and standard. System administrators, they are the ones that keep the lights on. They're the ones that we call at the 11th hour at 2 o'clock in the morning saying, hey, something's broken, come call us. It's reducing their cognitive load. They keep on focusing on operational aspects of their role, and they don't have to worry about making sure that the platform is set to a certain standard. That then obviously ties in with the last two, which is cybersecurity specialists. So platform engineers, by default, they're cybersecurity conscious. They have that DNA baked into them. That's where the governance comes into play, building controlled assets that are shared across the entire ecosystem. And again, the site reliability engineers are focusing on making sure that these applications are consistent and controlled, and they play in that part with making sure they don't have to focus on 6 different products, doing 6 different things of infrastructure as code. There is a common control set across all 6 applications.
So let's just talk about some principles. So I think the key thing as a platform engineer is the developer or data engineer, they're really the customer. So it's about working together to understand their pain points and problems and making their lives easier. So a key component of that is we need to treat the platform like a product. So as a product, it's got a backlog, a product owner. There's things that are evolving. It's not a very stagnant thing. So there's always that kind of continual improvement type things. And it's also about self-service and automation. So moving from a reactive world to more of a proactive world and making the tools and capabilities and platforms available through various self-service mechanisms, and a very heavy promotion on automation. And lastly, to be able to improve and do things well, you need to have a good understanding and being able to discover and observe what's happening. So getting visibility into the platform, how it's being used, that allows you to kind of feed back into that cycle around how we're going to improve these things and make them better. So in terms of the journey, where to start, so we need to define the problem space first. So talking to people, when do you start developing a platform engineering team, and kind of what is that charter? So you need to really understand that problem space. And again, it comes back to working with the developers, the data engineers, find out what they're doing and going through that cycle, and how can you help improve that. Another key component is maintaining a balance between reusable and flexible or adaptable. So it's almost this customization versus configuration. You don't want to go and build all these snowflakes for people to go and consume, because then it makes it harder to be standardized. But you need to give a little bit of wiggle room along that golden path to make sure that there's some elements of configuration that can be changed or adapted based on the problem they're trying to solve. As with cloud, it's evergreen, things are changing, so you really need to stay ahead of the curve, understanding there's new capabilities, products, tools. We talked this morning about the platform observability tools and security tools. There's a lot of consolidation happening in that space and understanding those things that are there. So being able to look at those and understand how can we leverage them is going to be super important. And lastly, building confidence by being a model of reliability and trust. Generally, developers and infrastructure engineers don't generally talk to each other. So taking that kind of front step and making them aware and how you can help them and make their life better is really a key part about working together and kind of achieving more.
So Now to the lessons to share, and we have so many lessons in this landscape. We've been in the infrastructure engineering life for probably a good 10 years ourselves, and I've built many data platforms that have existed for a great couple of years and then died because they've had a painful death because no one was maintaining and developing them. I've come back to Insight. We had about 13 different data platform offerings over a course of a 2-year period that I could see in repos. It's about tying all that together. So some of the lessons that I want to share with you today is not try to build Rome in a day. So many people with platform engineering, when they'll go with infrastructure as code, they will try to make this big beast that is absolutely doing all the bells and whistles, and the developer that's going to consuming that platform is using a vertical slice or a little horizontal nugget of the entire ecosystem. So that is absolutely the second point there. It's build iteratively and build lean. So it's focusing on making sure that you are building for the purpose that you have, and those are your people. So that's investing in the people, not necessarily technology. Platform engineering has the failed trade of basically someone's doing something else. Yeah, let's say you could pull an open source repo. There's a couple from Azure that are pretty big and monolithic in size. People go, oh great, that's the standard. We'll take that and we'll build it and we'll make that our platform engineering standard internally. But they don't focus on what's important, which is the people. You're as facilitating the developers and building their applications, they're building their solutions on integration platforms, whatever it may be. They need to be able to make sure that their platform is going to be fit for purpose for them. That's where 4 comes in, so leverage existing, don't start again. How many times have we had a conversation, Tulpy, about Azure Foundations, and we see customers literally go, oh, we need a new platform because we've built it this way 6 years ago and it's no longer up to date. Use existing and just build and adopt on that, and focus on making sure that when you iteratively approach, it's coming back to that whole DevOps philosophy, right? We iteratively improve our code. Infrastructure people don't have that, I guess, that headspace to think like that sometimes. So as platform engineers, we are focusing on making sure that we bring some of those very good developer concepts and bring it into that space. So that's the last point, is the business focus. So again, customers come to us all the time, say we want to rebuild foundations and all that kind of stuff, but the business needs are usually just associated with they want to use a particular feature, say like integration services in Azure. They will be focusing on a particular component. You can build a platform for that, not the whole monolithic across the entire board. And then I focused on 2 to 3 to 5. I didn't focus on the first one. I think people get this wrong, especially in infrastructure engineers and system administrators. They'll tend to do a lot of click ops. If you are in this space or you're looking to develop this space, spend the time to do it first in automation. Write some code, write it in PowerShell, write it in a CLI, write some calls, write a Terraform configuration file. It might take you 3 or 4 days extra to do that because you're learning that concept, but once you've got that, you've now got a pattern. That pattern can be used on the next solution. So many times we see customers, organisation, people, they will spend 2 or 3 days struggling with it, fail, go, I can't do this, and they go off and back they go to things like the portals and start clicking through, or consoles and start clicking through that. So that's 5 real key things that I would love people to take away from today about platform engineering is this: don't build Rotom a day. So many people do it and they end up with big monolithic platforms that don't fit purpose, don't fit need. Technology evolves and becomes out of hand and out of scope.
And just relating to what Trent said, it's about iteration with minimal viable products, so don't try to do a big bang. So if it's too heavy, then it's wrong. The absolutely worst thing a platform engineer can do is go to a developer and say, here, I've built
Here's your data platform.
Here's your nice shiny product, go off and do it now. So it really needs the conversation and kind of communication channels to work together, and then building and iterating on that and making it better. And that's essentially what a platform is that's what a product is rather than a platform or a project. So it's about that continuous integration and always making things better, because that's how we're going to improve and do things better as well.
Bang on.
And if that's the end, I can't believe we get under time.
We absolutely nailed that. It was 25 seconds. That's perfect.
Perfect. Thanks.
Questions?
Oh, I'm coming. Hang on.
Hi guys, Thank you for presentation, quite a good one. My question is probably about mindset. Like you mentioned that platform can help developer to fix this initial load that can be overwhelming and moving this load to a special team or person who look after this platform or looking after the templates, et cetera, et cetera. The mindset is a bit controversial with DevOps, because DevOps, you build it, you own it. Now we have developer who have all this help from another team, and when developer builds something and it doesn't work, oh, it's not my problem. It's a problem with the platform. So we just send it back to platform to fix. How do you guys deal with these issues?
That's a really good question. It comes back to that team, platform engineering, being basically the service provider. So for us at Insight, we are building these platforms, but we are servitude to other teams that are actually going out and delivering it. So when you talk about from the DevOps culture perspective, we are integrated into those other teams like a virtual team that sits around them. So it's not necessarily we're by ourselves building our platforms and say, here you go, we've built this big data platform or integration platform, and this is what we have built you got to use it. No, we are involved in those teams, but virtually dropping in when needed, helping support when those people are coming through, and collaborating in that sense. So one of the big things, and I think that's one of the key call-outs, and we did have a slide that was hidden that we didn't talk to, was sometimes platform engineering, they go, oh great, now we've got another team that is going to maintain a platform. How does that go and align with DevOps culture? It's about making sure that this function, this team, virtual teaming, whatever you want to call it, is integrating with your existing cohorts of developers and people. And to be honest with you, we've been involved in this game for 10 odd years. We still have this us versus them game in DevOps. You know, there's this operations team that go, I just want to click a green button and it's going to deploy. Infrastructure is set, all that kind of stuff. It is another way of trying to connect those dots. As a community, as a whole, as an industry, have we got this right? I don't think so. I wouldn't be surprised in maybe 3 or 4 years' time we'll be talking about platform engineering 3.0, and there'll be another topic around that.
All right, thanks. We've got another question over here.
Thank you for the talk. My question will be more on the platform that is being built by the DevOps team, for example, or the platform team. So in terms of how do we make sure that the platform being built will be used by the developers? Or how do we manage expectation that we build this platform and then we introduce to the developers? How much time does it take to really expect from them that they will eventually learn how to use it and brings value to the company?
It kind of depends on your maturity of each different company. Like a lot of people say platform engineering is just DevOps people talking to each other. So it's an evolution of that. So it depends on your starting point and where you're starting from. But you need to make sure that you're working together. And as to the question before, it's probably just a mindset change and shifting of the way that things used to be done. Because if it's this kind of throw over the fence and it's your problem, it'll never work. So it's about feedback loops and understanding what are their day-to-day challenges, what are the things that we can help solve, especially when you look at like Kubernetes, right? There's networking, security. To find somebody and to scale that understands a Kubernetes stack end to end is quite hard.
Yep.
So how can you then take the heavy lifting away from them, provide them that platform, and then work with them to make sure that it's evolving and suits their needs. Yeah. As Trent said, it'll change. I think it'll go through these kind of cycles.
Awesome, thanks. One more back here.
Thanks for the talk. You mentioned virtual teams. How do you see this playing out in a company which is global and has multiple technology teams supporting different regions? Thanks.
Yeah, so for anyone who doesn't know Insight is a global organization. So I'm part of the APAC region. So a large part, or not a large part, a certain component of my role is working with my counterparts in the other regions to kind of bring this together. In a global organization, it's a more slow moving, like almost trying to shift the Titanic. It depends on where you're coming from. The way that we knew we needed something like this is within the APAC region, we had various different teams building different things. Then you extrapolate that to North America and the other regions, you had a lot of stuff that was being built. So there's a lot of technical debt that was there. So without bringing that all together, and a lot of that first part was just saying, here's everything that we have, which stuff can we kind of consolidate, which stuff can we cull, and starting from that. So you do have to be a little bit ruthless, to be honest. Otherwise, you just go through this death by 1,000 cuts and kind of not get anywhere.
All right, cool. We've got time for one more question. Anybody want to ask a question?
This man here had his hand up all through the session. I think he's got a poignant question.
First thing, love the shirt. I noticed.
If you want the shirt, Dean Wall up front here can get you sort you one out.
Thanks, Dean. I know Dean. I owe him a beer. The key question I've got is, how do you get feedback and how do you exit? So they're pretty loaded questions.
Yep.
If devs are your customers, devs are terrible at setting priorities.
Yep.
They have no idea what the business want. Sorry, team. I've recent experience, which we can chat over a beer, is a key example of someone just burning 4 months on something that none of us wanted.
Yep.
And how do you exit, or is it a long-term play? And if you are in the team long-term, how do you scale? So we just build 5 new products. How do you manage those 5 new teams?